Good evening, students. Absolutely wonderful to see you this evening. So I'm very, very happy, and I congratulate all the students who have done excellent in the paper. So we have seen that today's JEE mains paper, mathematics, as usual, they have maintained the same standards. So question paper was lengthy, and a lot of calculations were there associated. And then there was also a good coverage of all the topics. Similarly, in physics, we were able to see that reasonably good coverage has been made in all the topics, along with most of the questions being directly like a formula based or touching concept only at the periphery level. So likewise, chemistry also reasonably good coverage has been made. So mostly students are saying that except for mathematics, physics, and chemistry were solvable. So what we shall do is, now I shall be discussing the physics paper. So I'll be very quickly taking you through the questions. There have been questions in electrostatics, based on a concept of dipole, based on a concept of the charge present on the surface of a metal conductor. There have been questions also basing on the concept of capacitors. There are also questions asked from geometrical optics, based on a concept of refraction at a spherical surface, questions basing on thin prism, questions also asked from topic of elasticity, questions from fluid statics, and also thermodynamics. So without much complication, you can see that there was a uniform distribution of the questions. So I encourage the children, those who are still continuing the preparation, please go ahead in solving the PYQs. Let us solve the questions one after the other. I will very quickly take you through the discussion. So let us solve the paper. First question. So let's see, there are two metal conductors which are given. Two metal conductors are given. So then both are connected with the help of a wire. And then you can see that when we are closing this, there is a distribution of the charge. So this has radius r, which is about 8 centimeter. This has radius r2, which is about 18 centimeter. So it is based on the properties of the metal conductor. So we're going to take this part into account. So when the switch is closed there and the system comes to what is called equilibrium, you are asked to identify ratio of the electric fields on the surface of the first sphere to that of the second sphere. So how do we identify? We know that the property of a metal conductor is that charge resides on the outer surface, and the electric field which is present on the periphery is given by E is equal to sigma by epsilon naught. So this is the electric field on the surface of the conductor. So we're going to take this. We also know that for a metal conductor, sigma is proportional to 1 by r. So that is surface charge density varies inversely with the radius of curvature. I'll just take this into account. So we can understand that E is proportional to 1 by r. So here if the electric field is E1, here if the electric field is E2, then you're going to have E1 upon E2 will be equal to 2 upon R1. The value of R2 is 18 centimeter. The value of R1 is 8 centimeter. So it's going to be 18 divided by 8. So that is the value of the ratio of the electric field. So that was a simple question which came from electrostatics. Let's go to the next question. Suppose you take capacitors. So in the next question, one capacitor is mentioned. And then you have insertion of the dielectric. Okay, so the space between the capacitance between the two metal plates is D. You have a dielectric of constant K is equal to 5, which has been introduced. You are asked to calculate the percentage increase in the capacitance of the system. So this is the original value, this is the new value. So what is the percentage increase in the capacitance? Let's calculate. You have this empty capacitor. So capacitance C is equal to epsilon naught A upon D. You have this new capacitance, which is given by epsilon naught A by D minus T plus T upon K. So this is the value of the new capacitor. Just a simple formula which has been taken into account. So this is without the dielectric. So there is empty space, and this is with dielectric. which is partially filled, and everyone is familiar with this equation. So now taking this into account, so you are asked to calculate C nu minus C naught divided by C naught into 100. This is the value which has to be identified. So the increase in the value of the capacitance, right? You have injected the capacitor. So how is the capacitance increasing? So when you are actually injecting this, we know that with the injection of the dielectric, capacitance will increase in the process. So we can easily calculate epsilon naught A by D minus the thickness will be D by 2. So D by 2 minus D by A. So that gives you epsilon naught A by D by 2 minus D by 2K. So you can have epsilon this will be plus and this will be plus D by 2 outside. So this will be K plus 1 upon K. So you have K by that will become C naught. So you have C naught divided by 1. So this is what you're going to get. So now this is the new capacitance. So new capacitance by original capacitance is 2K by K plus 1. So 2 into the dielectric constant is given to be 5. So 2 into 5 divided by 5 plus that is 10 divided by 6. Okay, so that is 5, 3. So you now write the increase. So we can easily write 5 by 3 minus 1 divided by, okay, putting it to C naught divided by C naught. So you see this will be 2 by 3 into 100 percentage change. So that is 0.6. So in this way, dear students, very easily it was a okay solvable question. So just empty dielectric, what do you call empty capacitor with dielectric. So easily okay, this is solvable question. Just mostly like formula based. Let's go for one more question, which came from the concept of prism from the geometrical optics. So the question is, there is a thin prism. There is a thin prism with the angle of the prism being A. The refractive index of the prism is 1.5. You are asked to calculate the ratio of the angle of the prism to the deviation that is generated. Angle of the prism to the deviation generated. So all the students know the equation for thin prism, that is the deviation generated will be mu minus 1 into A. So therefore, if you write A upon delta, so we shall have 1 by mu minus 1. So 1 by 1.5 minus 1. So that is 1 by 0.5, that will be 2. So therefore, the ratio A by delta simply comes out to be 2. So this is one question which came from geometrical optics. Let's look at one question which came from the wave optics. So you know that in wave optics, we talk about YDSC. Another concept is about the concept of diffraction. So interference, diffraction, and polarization. So questions have appeared from the concept of diffraction. So the question, as per the inputs given by the children, so the question is, you have a single slit diffraction pattern for which the wavelength of 620 nanometer has been used. The slit width is given to be something like 0.2 millimeter. So you're asked to calculate what is the width of the central maxima. This is also simple direct question, finding the width of the central maxima. So we know that the diffraction pattern, all right, will be because of the superposition of the secondary wavelengths. And we can see that, okay, so this is how the diffraction pattern will be there. This value is 1. So this is the first secondary minima. So the distance between the first secondary minima on either side, this will give you the free width. So in fact, if you take this to take on by d, our lambda by d, this side is also lambda d by d. So 2y will be 2 lambda d by d. This is the linear fringe width. But then if you take this y divided by capital D, that gives you the angular width. So therefore, now you can write, okay, in this particular case, y by d, which will be our theta. So if you take 2y, this will be 2 theta. So simply you shall have lambda d divided by small. So we have the value of lambda. So I think d is given to be 1 meter. So lambda is available, D is available, spot is available. You can get the width of the angular width of the central maxima. So this is a simple question which is easily solvable. Next question is again from electrostatic, simply formula based, basing on the concept of dipoles. So mostly in mains we are able to see that questions are formula based. Let's see this question. So you have the x-axis and y-axis. So one dipole is placed like this. This is one dipole. There's one dipole which is placed like this. So this dipole P1, this is dipole P2. At a point C, he says that in the question, the angle made by the resultant electric field. This is the resultant electric field, which is making x-axis. This is the resultant field. You are asked to calculate the ratio of the dipole moment. So what is P1 by P2? How much is this value? You are asked to calculate this. So we know that if you take this for P1, it is an equatorial, it is the axial line. And for P2, we know this will be the equatorial line. So the electric field, okay, we take it. So you can see that. So this is the direction of the electric field of P2. So which will be the equatorial line for P2. So it is given by Kp divided by Rq. Where if you take P1, this is the axial line. So the value here will be 2 Kp divided by Rq. So this is P1 and this is the P2. So we know that if you take tan 60 degree, so you shall easily write electric field due to 2, this is electric field due to 1. So if you take this into account, so this is so easily you can write. Okay, shift this vector parallel itself. So this will be our E2, this will be our E1 along this line. This will be our E1 along this line. So therefore, tan 60 will be E2 divided by E1. So E2 means this value. K32 divided by R cube divided by, when you talk about the value of E1, it is K3 divided by R cube. So and then E1 is there, also we cancel. So tan 63, which will be our P2 divided by P1. So times P1. So 2, 3 is a P2 by P1. So therefore P1 by P2 will be 1 by 2 root 3. So that's how you can see that you can calculate the values of the electric fields, value of the ratio of the dipoles, electric dipole moments. All right. So this is a simple formula based question. I hope all the students would have definitely solved this question. Let's go to the next question. You see, this is another simple question which came from the chapter called of the photoelectric effect. So modern physics, we know that every year questions will be coming. So another simple question appeared. So you have a photosensitive surface. When light of wavelength lambda naught is incident on the metal surface, so the stopping potential, stopping potential was found to be 4 times V. So when this is incident like this, so the stopping potential is found to be 4 times V naught. Suppose you're trying to use another wavelength of 3 times lambda naught, the same stopping potential has now become V naught. So stopping potential is actually this value. So therefore, for one value, it is this the potential, for another the different order of the potential. Now, taking this into account, you are asked to calculate what is the work function. You're asked to calculate what is called the work function of the metal. So let's try to identify the simple formula based everyone would have solved this. Hc by lambda naught is equal to work function plus stopping potential. So E times 4 V naught. Similarly, in the second case, when you write Hc by 3 times lambda naught, so you get W naught plus E times V naught. You can directly take this E V naught, substitute here. So the value of work function comes out to be Hc divided by 9 times lambda naught. So a simple direct formula based question. So I hope all the students would have successfully solved this. Another interesting question, which is again a formula based question which appeared from the chapter called surface tension. So the question everybody should be well fully aware because we have solved a lot of questions based on this particular concept. So you see there are 512 drops, 12 drops of water, and all these 500 drops of water are converting into a single drop. Okay, so look at a single droplet. You have to get the difference of the energy when this large number of droplets convert into a single droplet. Assume the T is the surface tension. So we know that large number of identical droplets combining into a single drop. So if you write the volume, so total mass is conserved. So by taking the volumes by 3 pi small r cube into n drops will become 4 by 3 pi capital R cube. So this will cancel out. So you will have the radius of the new drop 1 by 3 into R. So this is the radius of the new drop. So let us write the surface energy of the large number of droplets. So E1 N into surface energy 4 pi, and we write the final pi, small r square. So whole thing into surface tension T. That's right. So you can easily now calculate the change in the energy. Change in the energy comes out to be E2 minus E1. With all the details provided, very easily we can calculate R is equal to 512 upon 1 by 3 into R. That gives you 8R. So you can do the substitution here and you can evaluate the answer. So this is another simple formula-based question. I hope all students would have successfully solved this question. Now, there's one interesting and very simple question which also came from the chapter of elasticity. Just by looking at the question, people can easily answer. See, there is a wire which has been taken. The weight of the wire, weight of the string on the wire is W, and the weight of this is also W. The string has length N. You are asked to calculate the stress at a distance L by 3 from the fixed end. Stress at a distance of L by 3 from the fixed end is given as W by A plus 2W by gamma into A. Okay, so that's the stress at the point P. Okay, so you're asked to calculate the value of gamma. So what is the value of gamma? That has to be identified. So let's quickly calculate this. This is 1/3 length of the string. It holds a W by 3. This is 2/3 length of the string. So this will hold 2W by 3. Since you are looking for the stress at this point, where the area of cross section is A. So the stress is written as force by area. So this is one load, this is another load. So total load you can write W by A plus 2W by 3 times A. So in fact this will be 5W by 3A. So we can see that the value that which is asked in the question is simply 3. So this is how we can see that it's a simple straightforward question. In fact, the moment you look at the diagram without solving itself, you can come to the conclusion. Now, there is one interesting question which again came from geometrical optics, which is the concept of refraction at a curved surface. Let us quickly solve this question also. So you have a surface, curved surface. It is given that the radius of curvature is 20 centimeter. Refractive index is 1.5. Here refractive index is 1. Okay, so there is an object whose height is 2 centimeter, and then this object is placed at a distance of 40 centimeter. So I asked to calculate, find height of the image. So what is image height? So we already are comfortable with the formula. So height of the image by height of the object magnification, which is given by u2 into v divided by u. How are you going to get the value of this? Object distance is already mentioned, which is given as 40 centimeters. So easily we can calculate mu1 by minus u plus mu2 by v is equal to mu2 minus mu1 upon radius of curvature r. So 1 by minus of minus 40 plus say, we use the negative sign as per the sign convention, plus mu2 is 1.5 divided by v is equal to 1.5 minus 1 divided by radius of curvature is 20. The center of this curvature lies on the left side, which is opposite the direction of light, which will be minus 20 centimeters. Now taking this into account, this will be 1 by 40 plus 1.5 by v is equal to, so you shall have minus by 40. So 1.5 by v is equal to, yeah, minus 1 by 40 minus 1 by 40. So minus 40 will be equal to 3 by 2 times of v. So we can see that the value of v comes out to be minus, okay, this will be 20 times. So 2360 divided by 2. So that will be minus 30 centimeter. So minus 30 is lying on the same side. So directly we can take this value and put it here. So this will be mu1 by 2 height of the image. Height of the object is 2 centimeter. Measurement is above the principal axis, so it should be positive. So that will be 2 plus 2. And mu1 is 1, mu2 is 1.5. So that will be 3 by 2 into v is minus 30 divided by u is minus 40. So you can see this we cancelled out. So 1, 3, 3 is also 1. So this will be 1 by 2. So height of the image is equal to 2 divided by 2. That is 1 centimeter. So that's how you can see that it just for like a simple formula based. Most basic questions, first 10 questions of HC Verma. Okay, only of that particular level you can see that this simple questions or it can be easily solved. So most basic level questions of HC Verma, okay, have been asked and which are easily solvable. There's one more question which is from the concept of the magnetic effects of current. So here there are given two arrangements. The first is this one. So where you can see that, so in the center, the current is entering like this, it goes like this. So in the first center C1. So when a current I is flowing like this, magnetic field is generated. There is one more part in which okay, so we have this arrangement. So this is infinitely long. There is a second center. Okay, but the same radius R is maintained. So you're asked to calculate ratio of the magnetic field at C1 to ratio of the magnetic field at C2. So absolutely simple question. There are three segments. Segment number 2, segment number 3. So if you hold this wire, magnetic field is going inside due to the segment number 1. Due to this segment, you see magnetic field is again going inside. And due to this segment, again, you can see if you hold the wire, magnetic field is going inside. So all these segments generate a magnetic field which is going into the paper. So therefore, if you take this into account, we know that magnetic field is first segment plus second segment plus third segment. Okay, 1, 2, and 3. 3 segments. Easily we can calculate. So therefore, the magnetic field in the center C1 should be due to the first wire mu naught I by 4 pi into radius r into sine 90 plus sine 0 degree. Sine theta 1 plus sine theta 2. So here this is semi-infrared wire. So one end extends to 90, the other end angle is 0. The same thing happens for segment 1 and 2. So into 2 times plus field due to this portion. So mu naught I by 4 pi r into theta. This is 180 degree. So into theta that will become pi. So this will cancel out. So mu naught I by 4 r. So easily we can write mu naught I divided by 4 pi r. Sin 90 is 1 into 2 times plus mu naught I divided by 4 r. That's the magnetic field across the first center. Let's calculate the magnetic field across the second center. This again semi-infinite wire. So magnetic field at center C1 equal to segment 1 plus 2 plus 3. Okay, segment 1 plus segment 2 plus segment 3's contribution at the center. So we can calculate field to the first segment, second segment, and the third segment. What is the field due to the first segment? It is semi-infinite wire. So you calculate as mu naught I by 4 pi into sin theta 1 plus sin theta 2. Theta 1 extends, so theta 1 increases and it extends to 90 degree. Theta 2 is again 0. So therefore you can see that you can write as mu naught I by 4 pi r into sin theta 1, that is plus sin plus mu naught I, okay, by R into pi. Now the third wire, third segment, it is in line with that of the point of measurement. So the point we are trying to measure, it is exactly pointing in line. So it's in parallel. So therefore, the contribution of magnitude will be 0 because L bar cross R bar comes out to be 0. So therefore, the third segment doesn't contribute. So now taking this into account again, you can write that. So mu naught I by 4 pi R plus mu naught I by 4 pi R into pi. Now I'm going to magnitude at the center C2. So beta, what we can do is VC1 is there, VC2 is there, divide those two, and that will be your final answer. So easily we can calculate. So without any complication, this is also okay. Another interesting question which was asked in the examination. Okay, now coming to the questions from heat and thermodynamics. So for a diatomic gas, there is a diatomic gas given. Atomic gas. A diatomic gas is mentioned. You're asked to calculate the ratio of, find the ratio. Okay, ratio. Find the ratio of delta Q is to delta U is to delta W. Okay, and this is to be identified for what is called isobaric process. Okay, for a isobaric process. So children, so this is to be identified. Okay, so ratio of delta Q is to delta U is to delta W. We know that for a diatomic gas, okay, in general, when you write, suppose let the value of Q is to be identified. So we write NCP delta T. Take the value of delta U, internal energy. NCV delta T. How about NR delta T? We are familiar with this part. Now, you are talking about a diatomic gas. For a diatomic gas, so what is the value of Cp? It is 7R by 2. What is the value of Cv? It is 5R by 2. So now we can directly take this. So delta Q is to delta U is to delta W comes out to be, okay, 7R by 2 is to 5R by 2 is to R. That's a calculate. So now, if you remove a particular expression of 2, so answer becomes 7 is to 5 is to 2. So that is a simple, straightforward question. No need to do any mathematical calculation. Directly we can solve it. Okay, let me discuss one more question which came from thermodynamics only. This is also another basic question which is formula based. And then let's see how to solve this question. For an ideal gas, Cp is given to be 3R and Cv is given to be 2R. Okay, so Cp by Cv is 3 by 2. What is the work done by 1 mole of gas? So you have to get work done for N is equal to 1 mole. 1 mole of a gas in adiabatic expansion. So in adiabatic expansion, this is to be identified. So in adiabatic expansion, what is the work done? When the pressure is reduced from, okay, pressure is dropping from 8 bar to 1 bar. So most of the students are immediately confused what is the value of bar. So I encourage the students who are writing the examination tomorrow, be careful with the, okay, different forms of conversions. Okay. So anyhow, in this particular question, when we solve, we see that the units will cancel out. So there is no issue, but I encourage you that you also learn all the possible conversions. Taking this into account, so you're asked to calculate the work done by 1 mole of gas. Gamma. Ratio of the molar specific heats. How much is that? 3R divided by 2R. This is 1. So 3 by 2 is the value. Also, this is an adiabatic expansion. In an adiabatic expansion, we know that delta Q will be 0. So adiabatic expansion is commonly valid for what? Isolated system, for which delta Q will be 0. So when you take delta Q, that is delta U plus delta W. So see delta Q is coming out to be 0. So work done is minus delta U. So we let us take the modulus of it. Okay, so this is a value has to be done. So let's think about modulus of this. What is the work done in the process? So we know that this is expanding, so naturally internal energy will drop. So the negative sign is meaningful. Now, in this particular case, when we are looking at it, adiabatic expansion, when the pressure is reduced from 8 bar to 1 bar. So we know that when you're taking this part into account, so you can keep our 1 minus gamma and keep our gamma is a constant. Let's quickly calculate this. So P power P1 power 1 minus gamma into T1 power gamma is equal to P power 1 minus gamma into T2 power gamma. That's what we have. So let us calculate T2. The initial temperature mentioned in the question is 140 centigrade. You have to convert into Kelvin scale because are valid in the Kelvin scale part. So taking this into account, so T2 power gamma comes out to be T1 by T2 whole power 1 minus gamma into T1 power gamma. So that comes out to be T1 by 2 because the value of gamma is already calculated and that is 3 upon 2. So now taking this into account, directly we know that we can write this as NCV delta T. So number of volts is 1. CV is already given to be 2R into 2R into delta T. So T final minus T initial. So you calculate the value and that is how we can see that you are able to evaluate the amount of work done in the case of this expansion. So students, so these are the questions what we have in physics. Just another 2 questions. Let me quickly take you through that. Okay, I see some of the students are still sharing few more questions. Yeah, one of your favorites, units and dimensions. So this time, children were not discouraged. You were asked to write the dimensional formula of this. What is the dimensional formula of this? Now we know that this is the dimensional formula for what? Energy density. Energy density, which is energy by volume. Energy, which is ml square t power minus 2. Volume, L cube. So that becomes ml power minus 1 t power minus 2. That's a simple, okay, question based on units and dimensions. One more interesting question, very simple, easy to solve. Okay. The position vector of a particle is changing as 5 t power 4 by 40 I cap minus t2 by 3 j cap. Determine the acceleration of the object. Determine the acceleration of the object at t equal to 1 second. So let us see how to calculate that. So if you go with dt, that means the velocity one. Hence you have 5 by 40 into 4t cube into I cap minus 3t square by 3 j cap. So you see, you cancel out. So 4 ones, 4 tens, so that will become 1 by 2. So t cube upon 2 I cap minus t square j cap. So you got a velocity vector. Let us take the acceleration vector, which is dt bar by dt. So that will be 3t square by 2 into I cap minus 2t j cap. Let us calculate this value at t is equal to 1 second. So we're taking 1 second with 3 by 2 I cap, it will be 2 j cap. 3 by 2 I cap minus 2 j cap. So let's go for the modulus of this. When you check for the modulus, this will be root over. That will be okay. 16 plus 9, 25 upon 4, that will be 5 meter per second square. That's how we can see that we can calculate the value of the acceleration at t is equal to 1 second. One last question and we are through. So this question came from fluid statics. There is a cube of side, okay, 10 centimeter. He said the relative density of the cube is 0.4. 0.4 means 40% of the cube will be immersed in water. Okay, so this is what we have. They are going to place one small coin. When the coin, you can see that when a small coin is placed, this will sink extra by 0.3 centimeter. So because of the coin, the whole of the structure goes down by another 0.3 centimeter. So how do we calculate? Very simple. So we have M1, this is M2, this is original length L1. When you place the coin, this will be length L1, extra length L2 is added. So now if you identify this, you ask the weight of M2. So easily you can write an equation. Mg equal to the upthrust, which is volume inside. So you take okay, A at the side. So you have A square into L1 density of liquid into G. So volume of the liquid is split density of liquid into G. In the second case, you shall have M1 plus M2 into G is equal to A square into L1 plus L2 into density of liquid into G. You can note the difference of these two. Equation number 1, equation number 2, just to do 2 minus 1. When you do 2 minus 1, so you'll be left out with M2G is equal to A square into L2 into density of liquid into G. Just substitute the values. All values are available. Your answer comes out to be 0.3 Newton. So, dear students, as per the inputs given by all of your dear friends, all right, so we were able to get these questions. So you can see that there was uniform distribution, be it electrostatics, be it ray optics, be it wave optics, be it surface tension, be it fluid statics, thermodynamics. So you can see that there is a very good coverage. All were formula based. And I encourage every one of the students to very carefully, okay, go through the questions, keep going through the PYQs, keep solving the questions, don't lose the tempo. Okay, you need speed and accuracy. Be careful with the mistakes that you have committed in phase 1, and then you can see that your performance is going to be dynamic. So, dear students, thank you so much. Now we shall have match paper discussion. So, see you later. चलेगा आसियान सर हाँ क्लियर है Adiabatic. This reduce reduce very good. Is we get some red. Yes.
Yeah, hi students, good evening. I think all of you had a physics of paper discussion. Right? I think approximately 30 to 40 questions were discussed. And I think we must have talked about how the paper was compared with the last session. Right? Now, let us discuss about the mathematics. So, mathematics mainly show that when you compare with the last time to this time, uh, looked same. That means it was moderate to lengthy. There were certain questions. What are the questions we got till now? There were certain questions which easier. There were certain questions which are doable but lengthy. So ultimately, if you ask me, if it was somebody says how the math paper was, yes, it was doable. That is one. I always say that like your CPC, 5 marks question that we put as an objective question, which takes around 10 minutes to do, but only thing is your speed should be very fast. So there were around 7 to 8 questions which were actually discussing that. Right. So rather than going for the complete point to point, even we will go through all the concepts in each and every question. So let us start the question paper. This was question number one. Whatever we got from the sources, it may be our own students, maybe from the friends that we got. Uh, the number of 7-digit number that can be formed by using the digit 1, 2, 3, 5, 7. Okay? Such that each digit is used at least once. So it's easy question because that all a tough question. It was an easy question, right? So here he is saying that you have to use 1, 2, 3, 5, and 7. Okay? And such a that it should be a 7 number. So I put blanks 1, 2, 3, 4, 5, 6, 7. And so 1, 2, 3, 5, 7 will come. Because 5 is over. All of them came at least once. Now the game is how the remaining can be same, remaining can be different, but when it is same, these numbers will leave. So one will be 1, 2, 3, 5, 7. There can be 1, 1. There can be 1. There can be 1, 1. There can be 2, 2. There can be 3, 3. So on. There can be 7, 7. How many? 1, 2, 3, 4, 5. Maybe 5. Right? This is 5. Now, how many ways? Each combination will be 1, 2, 3, 4, 5, 6, 7, and one number will be twice. So we multiply this by 3. This is one case one, right? Which both are same. Now, both are different, one and different. So here, what we are going to do that we have 1, 2, 3, 4. Sorry, 1, 2, 3, 5, 5, 7. The last maybe 1, maybe 1, 3, maybe 1, 5. So among that combination, 1, 2, 3, 4, 5, 5, C2, that is 10 ways. Like here we have 5 ways. Here we have 10 ways. And each 10 multiplied by 1, 2, 3, 4, 5, 6, 7, 7. Okay? For two numbers like 1 and 1 and 2 and 2 repeated twice, that is 2 factorial, 2 factorial. So total, the number of ways is first is 5 into 7 factorial by 2 factorial plus 10 into 7 factorial by 2 factorial. 7 factorial can be common. It is 5 by 6 plus this by 4. So in total, I can go for 5 by 2 or I can sim and so 20 plus 60, 80. So 80 by 24 into 7. Only 20%. I can divide what. So this sum is easy, but only thing is calculation part makes a difference. Calculation is lengthy. This was question number one. Question number second. All our memory fixed. Simple question, but lengthy question. Simple but lengthy. It is based on a typical question where a triangle, the midpoint of the sides of a triangle are given. So ABC is a triangle. Midpoint of the sides The midpoints are 3 by 2, 7. Second midpoint is 5 by 2, 3. Third midpoint is 4, 5. Now we say if the insect triangle, so what else you would have asked? But yes, it is lengthy. So here the concept is if there is a triangle, if the midpoint are x1 by 1, x2 by 2, and x3 by 3, then A, B, C, obvious I can take it as alpha 1, beta 1, alpha 2, beta 2, alpha 3, beta 3. I would have gone, right? Then alpha 1 plus alpha 2 by 2 is x2. Like that, I would have got ABC, but directly this will be x2 plus x3 minus x1, comma, y2 plus y3 minus y2. In this concept, right? Same way for solving this. Let us see. This will be 4 divided by 5, comma 5, because again, so 5 plus 3, 8, 16, sorry, 5 8 minus 0, it is 0, comma 7 plus 3, 10, 10 minus 5, right? Again, 8 plus 11, 11 minus 5, 6, 6 by 2 is 3, 7 plus 5, 12 minus 3, 9. This is 8 plus 13, 13 minus 3 is 10 by 2 is 5. 5 plus 3, 8, 8 is 1. I think now triangle with vertices 0, 3, 9, 5, 1. Okay, for a triangle with vertices 0, 5, that is 8, assume that 3, 9, you can check the calculation, they are going for 1, 5, 1. Now, for this triangle, how do I got this? So, h, k, I can find the distance, this is B and this is C. I know this is C, this is B, this is A, and it is A plus B into 3 plus C into 5. 5 A plus B plus C. This is the formula. Come on, same for y coordinate. A into 5. A into 5 plus B into 9 plus C into 1 divided by A plus B. Now, all but finding the distance that we get. Right? So that how once it is only the length. It is long question. It's not a small question. But yes, concept we know. I know how to find A center. I know how to find the midpoint. That is question number 2. Question number 3. Good question. It's a very good question. It's not tough, it's a good question. Conceptual question. Because if you would have done limits properly, then only you get this. Right? Limits should be of a good solving sum. Here, limit x tend to 2 sine of x cube minus 5x square plus ax plus b by root of x minus 1 into log x minus. Right? 2, 3 things are used here. First is, he's saying this is given as n. So, I'm assuming maybe they are giving options. I don't know which type of option. So, maybe option 20 is something they're asking. So, the option is finite. If this is finite, definitely this should be of any one of the indeterminate form. Push and pull should be there. It's a finite one. So if the denominator is 0, so numerator that implies sine 0, x cube minus 5x square plus ax plus at x equal. This should become so 8 minus 20 plus 2a plus b is equal to 0. 2 plus b is equal to 0. I think all of you think. First relation is 2a plus b is equal to 12. Correct? 2a plus b. Now, after this, 2a plus b is equal to 12. This becomes 0. 2a, this becomes 0, 0, 0 by form. I can apply L hospital rule. So what we do? Sine of x cube minus 5x square plus 8x plus divided by x cube minus 5x square plus sin x by x form. It becomes sin x by x form. This will become 1. So assuming answer is finite. Now balancing it, I will do x cube minus 5x square plus 8x plus divided by x minus 1 into log of x minus 1 with the same limit. My entire thought process will concentrate on my entire thought process will be 1. So one bond I'm taking out, I'm going to the next one. X cube, I will take it from here. It is x cube minus 5x square plus 8 divided by 5. I rationalize this. This will become x into root of x minus 1 plus 1. यहाँ पे divided by log of x minus 1 limit x tend to 2. Why am I not taking that? Because 3 has become 1. So what this will be the same. Correct? It is same. Now what will I do? This after rationalization. This, now I have one more. Limit x tend to 0. Log of x plus 1 by x is 1. We all know that this here answer 1. Now if x minus 1, it is log by x goes to x minus 2. So this is x minus 2, x tend to 2. So this is 1. So what will I do? I multiply by x minus 2, I divide by x. This became 1 because of the limit. This is 2 because of this. So we take limit x tend to 2, x cube minus 5x square plus 5 x square minus 2x. Correct? It will be 2 here in the side. Am I correct? This is it. Now, this is 0 in the previous. We have taken this condition. This is 0. Now, this 0 is 0 form I can apply hospital rule. So, this becomes 3x square minus 10x plus 8 by 2x minus 2, limit x tend to 2. Don't forget into 2. This is an. Correct? Now, let us come back. Now, denominator is 2, so I can put this is 12 minus 20 plus 8 into 2 is equal to minus 8 plus 8. So 8 minus 8 is right. So one is 2a plus b. So I'll take this out. 2a plus b is 12, and this condition because of the value. So first is plus b, other is a minus a. It is 2 equations and 3 elements. But I want a plus b plus n. Yeah, very good question. That's what I told. It's a good question. So let us see. I'll write this as a plus b is equal to 12. Now this a plus a4, 8 plus m plus b is equal to 12. So a plus m plus b. So if any one of you got the answer 4, then the correct answer. If any one of you got the answer 4, that is a correct answer. Right? Answer is 4. Second calculation. Because going live, but most things should be correct. As for me, answer should be 4 if the calculation is right. That was question number 3. Let us go about question number 4. Again, good question. It is actually at this. And like last two before, you see, all lengthy. It is not that we can't read the answer. It may take around 3 minutes to get the answer. Right? And 3 minutes, how many answers you use? Good students, fine. I understand who have really mastered the speed, things are better. This is A sigma. K is given to us. Sn is given to me as 6 and Q. Right? Now he wants K. I know that terms 2 the term. I know that S plus 1 minus Sk is Kk plus 1. That's what I want. Correct? What is Sk? 6 into K plus 1 the whole cube minus 6 into K cube is equal to Ak plus 1. Let us find it out. Ak plus 1 is equal to 6 into K cube plus 3K square plus K plus 1 minus K cube. ये से कैंसिल फिर आ जाएगा Ak plus 1 हुआ हमारा 6 into 3K square plus 3K plus same AK. So not AK minus 1, AK. AK, if I take, AK will become K minus 3 into K minus 1 the whole square plus 3 into K minus 1 plus 1. Now, I need to subtract this to find it. K plus 1 minus K. क्या है? Subtract करो plus 6 का 6. A square minus B. 3 into this minus this. So A minus B 1, A plus B is 2K minus. Right? This minus this 3 into 1. Okay. Right? 1 minus 2 0. Here I have A plus 1 minus 6 into 3 to the 6. 6K. So AK plus 1 minus K plus AK plus 1 minus AK by 36 is K. So this is K. So sigma is K square. K square plus K. K is equal to 1 to 6. K is equal to 6. Right? K is equal to 1 to 6. So I think that is fine. K square cancel. So 2K minus 2. So it is 1 plus 2 plus 3 square plus 4 square plus 5 square plus 6 square. It is sum of square n in n plus 1 into 2 n plus 1 by 6. Right? That is the answer how it should be done. Good question, because work is there after doing this work that form. So what? So that was this is challenge. Nothing is there. Because if I put the value of pi, I get the answer. Pi is already this sine 10. You will understand it. This sine 50 degree. This sine 10. 70. Right? So this is sine 70 can be taken as sine 110. Right? Sine 70 can be 110 multiplied by theta. Sine 50 and sine 10. This will be sine theta, sine 60 minus theta, 10, sine 60 plus theta, 100. Now this is 1 by 4 sine 3 theta. So 150. 350. So it is 1/4 of sine of sine 350 is sine 30, sine 30 is 1 by 2. This is 1 by 8. So this right? When k is 1 by 8, I got sine of 10k pi by 3. Sine of 10k is 1 by 8 pi by 3. So sine of 5 pi by 12. Pi by 12 15, 15 by 75, sine 75 80, that is sine 45 30. You know the value still, right? Sine 45 cos 30 plus cos 45 sin 30. Cos 30. So it is root 3 plus 1 by 2 root 2. How the way the question was asked, I don't know, but this right. That was question number 5 previously. Question number 6. Very good. Some of good question, very good question. These are the questions where actually the student stuck. He's saying x down minus 1 plus 5. Sin x into sin plus 6 is 8. Obviously, he's taking a is minus 6. This is what done here. A is integer, then number of elements. He formed number of elements. A is integer. Okay. So first find the range. So range of sin x into sin x plus cos x. Right? So I can take it as sin x plus sin x cos x. That is 1 minus 2x by 2 in the form sin 2x by 2. ये हो जाएगा 1 by 2 plus sin x minus by 2. I think this slide would be 1 by 2 minus root 2 by 2 and 1 by 2 plus root 2 by 2 because sin x minus cos x by 2 minus root 2. So A का range हुआ 1 minus root 2 से लेके 1 plus root 2. You don't want A, you want x minus 1. Okay. Now ये क्या है 1 minus 0.414 by 2 से लेके minus A 2.414 by 2. So A कहाँ से minus 0.2 से लेके 1.2. Right? Minus 1.2 0 1. So A value 0 and 1. A can take the values either 0 or 1. Okay, granted. A can take the value 0. A can sin x into sin x, then I can take 0 or sin x into sin x plus cos x can take 1. So 0 either sin x 0 or sin x plus cos x. Now this is minus 5 plus 5 value. So x equal to minus 5, 0, 5. So यहाँ पे 3 value. All lying. I think should be square. Okay. I think so. यहाँ पे 3 value. Minus 5. Tan x minus 1. What values? Minus 5 by 4, 3 by 4. So x can be minus 5, 3 by 4. Right? Now this is 1 means either both 1 1 or minus 1 or root 2 1 by 2 with root 2 or minus. These are only two values, right? 1 1 is equal to 5 by 2 5 by 2 में 1 5 by 2 में 1 minus x equal to minus 5. 1 by 2 is 5 x equal to 5. Yeah. Right? And this yeah minus 5 by 4. Yes, minus 5 by 4 and minus 3 by 4. Minus ये minus 1 by root 2 by root 2 0 possible. Minus 3 by 4 में ये minus 1 by root 2 ये 1 by root 2 not possible. On so ये possible नहीं है. I have 1 2 3 4 5 6 7 8. There are 8. As per me, there are 8 values, but still 8. So this is the way it should be done. Number of variables. So that was question number 6. Let us go to question number 7. Like this question has come before. So easy question. If you ask me exactly nahi, but repeat it like that. Let us see. Slightly typo error. It is 36t r plus 1 is equal to 6 by k square minus 3 into 35 CR, right? He's asking the values of R and K. I'll check how many K, how many R we get. So we'll do that because we got on the question. You have one concept of NCR to be करने का. So n नीचे, R भी नीचे, n minus 1 CR minus 1. Further n by R. Really don't be अगला दूसरा n minus 2 C R minus 2. Like that we can keep. Happen 36 by R plus 1. 35 CR is equal to 6 by K square minus 3. 35 CR. K cancel. But don't forget, R should be less than equal to 2. मतलब R की R should be less than 2. So, उसके बाद 6 लिखा cancel. So I have 6 into K square minus 3 is equal to R plus 1. Correct? Right? And you know that R plus 1 should be greater than equal to 36. First, greater than equal to 0. It should be greater than equal to 0 because I want K. So K square minus 3 greater than equal to 0. K is either greater than equal to root 3 or K less than equal to scope. Second is because of this relation, I got 6 into K square minus 1, which is plus 1. R plus 1 should be less than equal to 6. Right? So K square minus 1. K square minus 3 into 6 is less than equal to 36. So K square minus 3 is less than equal to 6. K less than equal to K square less than equal to 1. K lies between minus 3 to plus 3. Yeah. So एक आया root 3 minus root 3. Root 3. एक आया 3 minus. एक कहता है K, एक कहता है number 6. So, fine. This is that. So I can go for here. So minus this minus 3. So I have minus 1 minus 2. Minus 1 minus 2. Right. So minus 2 minus 3. 2, 3. So so K given you 4 values and R less than equal to 35. R should be greater than equal to minus 0. So R can take value between 0 and 35. So R की ये set all integers K can be 4 values. Check whatever is asking the number of integers. So that is question number 7. Question number 8. This must is good. This you have to think how it is. This is log. This is exponential. Log based exponential may be the inverse of it. So what if you check it? Y is equal to log base 2 x square plus 4. So x square plus 4 is equal to 2 power y. X square is equal to 2 power y minus 4. X is root of 2 power y 1 minus 4. That is f inverse x is equal to root of 2 power x minus 4. So ये क्वेश्चन जो है वो है a to b f of x dx plus integral f inverse a f inverse b f inverse x. So if you solve it, it's not f of b minus a f of a. So b is 2 to 3. F of b is log to the base 2 2 root 3, 12, 16 minus 8 into f of a 0. So 2 root 3 into 4. 2 by 4. Answer is 8, 3. Right? Good question. But if you don't know the concept, it will take time. That was question number 8. Question number 9. Okay. This question is important. So the students who are attempting tomorrow, day after tomorrow, other exams, please go through the concept of A to B f of x dx plus f inverse A to f inverse B, f inverse x dx is equal to B f of x minus. Please go. Right? Simple question. ये आपका ऐसे ब्रैकेट में ना. So integral 0 to 1 e power x plus e power minus x by 0 factorial dx plus integral 1 to 2 e power x plus e power minus x divided by factorial dx plus integral 2 e power x plus दोनों से because 0 factor second is 1 factor, so I can take integral 0 to e power x plus e power minus x dx plus integral 2 e power x plus e power. So let us go for ये तो e square minus 1 plus e power minus 2 1 इंटीग्रेट e power x e power minus, that's why ये minus है. ये cancel e power 2 minus e power ऐसे 1 by 2 into e power x, so e cube minus e square, right? E cube minus e power minus this. I think this can pick up again, right? So that was. So some questions are easy. Directly can do it. Okay. This question is based on probability. I think possibly one of the questions which are prominent and asked as the question that we got. Only question. Okay. So ABC belongs to 1, 2, 3, 4. Chota 1, 2, 3, 4. Okay. So ax square plus 2 root bx plus c is greater than 0 for all. Means this quantity equation is always positive. That is only possible only when groups are imaginary. Let me go there. So the a b square minus 4ac is less than 0. 2b square is less than c. Now ABC comes. ABC are 1, 2, and 3 and 4. So first number of places. A has got 4 options, B has got 4, that is 64. Half problem solved. Total number of the probability 64. Now number of failure. Okay. So I put one by one. This is a favorable condition. B when B is equal to 1, AC is greater than 2. I know that A total A B can take in 4 16 ways. 16 ways less than 2. Is 1 1 1 2 2 1. A1 C1 A1 C2 either 2 or less. Greater than 2 I want. So 16 minus 3, how many? 13. So B is equal to 1, it will give me 13 pieces. Now I go for B is equal to 1, 1, 2, 3, 4. B2 will give me AC greater than 8. AC greater than I can count because I put 1, 2, 1, 3, 1, 4 is only 4. 2, 3, 2, 4 is 8, not possible. 3, 3, 3, 4, 4, 3, 4. So there are 4 cases. Right? When B is equal to 3 or B is equal to 4, in that case it will be 18 AC greater than 18. I don't think so possible. 16 and AC 32. AC greater than 32 also. So 17 cases, I think. So probability of the favorable cases, number of favorable cases by total number of cases, that is the Kinematics, 17 by 64. He's asking to find GCD and present. So 64 plus 17 and anyone getting it was a correct, right? So this is the question. Simple differential equation. Not all difficulty. That was there. So it is 1 plus minus dy by dx plus cos is equal to minus or x. I feel it's cos, but still solve it. I feel it's cos, but anyway, that is dy by dx plus cos x by 1 plus sin x into y is equal to minus cos x. I feel cos by 1 plus x. So e power it is dy by dx plus linear differential equation. So e power integral concept. So e power integral cos x divided by 1 plus sin x sine of cos. So it will be e power log of 1 plus sin x, that is sin x. So I get it as y into 1 plus sin x is equal to integral of minus x by sin x minus cot is cosecant square y into 1 plus sin x. Please go ahead for what it is. That was it I was saying. Should be 0 is not defined here. 0 will define here. 0 cosecant. So minus cosecant. So that's the reason slightly bother whether it's there or not. If it's there, then take its sign and bother. Take its sign and bother. Right? So this is how a solution can be done. Right? In this best question, one of the questions based on coordinates, usually it comes on ellipse, hyperbola, parabola. Some easy questions are there, which are directly, that means directly they are based on the concept given in NCERT. Eccentricity, latus rectum, focal chord, or even your confocal, those kind of based on AE minus AE or eccentricity formula, based on this only things. Right? So ellipse is there, passes, okay, with ellipse is there, it passes eccentricity, find length, let us length is to be square. I am assuming A greater than B, assuming A greater than B. So 2B square. So first is passing. So I'll get it as 9 by A square plus 16 by B square. Eccentricity, if A is greater than B, I'm assuming. Second, I get that E square is equal to 1 minus B square by A square. And E square is 5 by B. So B square by A square is 4 by B. So 4 by B. So after this, what I have to solve this to get my answer. Let's see. I can put it here. 9 by A square plus 16 by B square. 4 by 9 is equal to 1. This goes up. So 9 by A square plus 4 goes up. 36 by A square is equal. So A square 5. A is 15, 9 by 15. So 3. A is 3, right? And B square is 4 by 9 is 4 by 9 is so 9 by 6. So B square is 20. I got both. B square 20, A 3 into 5. So it is 2 into 20 by 3 root 5. So I take 2 into 4 into 5 by 3 root 5. So root 5 cancel. So it is 8 by 3 root 5. It should be one of the options with the option is. So this is the question in which purely based on concepts. ज़्यादा बाहर नहीं है. Complex number. So today only saw the students asking that based on complex number questions, how they will come. If you're not understanding anything, put Z as so that I have simply complex number, real part, real imaginary. So I take it as 50 into 2x by 1 plus 3 iota minus y by 1 minus 2 iota is equal to 31 plus 70. If the calculation is fine. So you won't solve it. This is 50 multiplied by 2x by this is 10 ले लो ऊपर क्या आएगा राशि 1 minus 3 आएगा minus y इसको 5 ले लो it is 1 plus 2 आएगा is equal to 31 plus 10 सॉल्व कर लेते हैं ये भी आपको 1 by 5 आएगा 50 into x by 5 into 1 minus 3 आएगा minus 5 into 1 plus 2 आएगा is equal to 31 plus solve कर सकते हैं ये सिर्फ 10 आ रहा है so 10x minus 3 into x minus 10 by minus 20 iota is equal to 31 plus 70. Please go for the real and imaginary part. So 10x minus 5 is equal to 31. That is one part. Second is minus 10. So 30x plus 20y is equal to minus 7. Right? So solving this two, I think we can find. Divide by 10, x and y, substitute x, 10. Right? So I can solve this. 10 is already there. So two equations. One is 10x minus 10y is equal to 31. Second is 30x plus 20y is equal to minus. Multiply 2. So 20x minus 20y is 2. I so 50x is equal to 1. Right? So validate. If the point of intersection of the lines, these two, good question. It is good question. Lengthy involves concept. Without concept, you can't. If you have visualization, you can't do this question. First, it is saying the point of intersection means both are coplanar and they intersect. So two conditions will come. One is the common point of intersection, second is coplanarity. So first I go for coplanarity. What is coplanarity condition? Determinant of x2 minus x1, y2 minus y1, z2 minus z1, n1, m1, n1, n2, m2, n2 should be 3. This should be 3. That is the value should be 3. Right? So यहाँ पे क्या है आपके पास? -1, -a, -b, -1, 2b, 2a. So x2 minus x1, 3, b plus a, 2a plus b plus 1, 3, 5, 7, 1, 4, 6. Right? If I solve this, 3 into 35 minus 28 minus a plus b into 21 minus plus 2a plus b plus 1 into 12 minus. If I put check कर लेते हैं, तो that we get 3 into 35 minus 28 minus a plus b into 21 minus 7, 2a plus b plus 1 into 12 minus. So ये कितना बेटा? This is 721 minus a plus b into 14 plus 2a plus b plus 1 into 7. 7 cancels. This with 14 and 21 goes. I get it as 3 minus 2 into a plus b plus 2a plus b plus 1. I think it's fine. Right? Couldn't always cancel that. So I'm left with 3 minus 2b plus b plus 1 is equal to 0. So b is 1. So I got b4. Correct? B4 is right? B4. So B4 will give me I'll B4 will give me x plus 1 by 3 x plus 1 by 3 is equal to y plus a by 5. X plus 1 by 3 is equal to y plus a by 5 is equal to B4 z plus 5 by 7. Second, x minus 2 by 1 y minus 4 z minus 2a by 7. Now, one is programming. So I'll take the concept of intersection. So intersection will be is equal to intersection will be is equal to R1 is equal to R2. Right? So I can take this as 3R1 minus 1, 5R1 minus 8, 7R1 minus 5, R2 plus 2, 4R2 plus 4, 7R2 plus 2. So when I put it, I get one more relation. So using that, I can find the value of A. Right? So that gave me the value. So these were the 14 questions here, student, that we right. Remaining show tomorrow when we update the latest solution. Two things I want to tell you. Paper was a bit lengthy, but not tough. All the questions were doable. If you practice this consistently, things would have been different. So the students who didn't give the examination today, good chance, go through all the questions, understand the concept, and keep on with the links and get the solution in fast way. And you can come and kindly let us know. Anyone thank you. The next chemistry teacher will come and take it. Just wait for them. Thank you.
Hi students. So you can see this paper of chemistry was highly scoring. Even from the question were highly scoring from all the sections. Physical chemistry questions were to the point and not calculative, and they were very direct questions. Organic questions they have come from directly from the new reaction, and inorganic have come directly from the NCRT. So overall paper we can rate as easy to moderate, but it was not tough at all, and highly scoring paper it was, and highly conceptual paper it was, but it was not on the tougher side. It was on the easy to moderate side. So let us see. Let's have a discussion of the paper. Let's see the concept. Uh, yes. So let's see this. So if you look at this question here, question number this question here, it is from ionic solubility product. And see this question is a very good question. And there are nine concept of KSP and solubility relation. So you can see the question here. See, there are two saturated salt given. First one is silver chromate is given, is given, and second is KSP of AgBr is given. But see, there can be two type of question framed in this time. But in this question, these two salt solutions are separated. They are not mixed up in the same container. So actually, it is not a question of simultaneous solubility, but it is a question of separate question. You can see. See, the first one is we have silver chromate saturated. So you know that silver chromate saturated solution at equilibrium. These ions are there, 2Ag plus and chromate ion. So these two are at equilibrium with each other. And let us say that let us of this salt S. So S concentration will be 2S S. So KSP for this salt will be at equilibrium. So KSP is given by, you know, KSP is equal to ionic product. So KSP is equal to constitution of silver ion square into constitution of chromate ion. So that is the 2S whole square into S. So that is 4S cube. So that is the KSP of this salt, which is 4S cube. And KSP value is given to you. How much? You see, KSP is given to you 32x. So we are getting that. We are getting x is equal to 4S cube. So we are getting that. So from here we can find the solubility of this salt. How much? Solubility S cube is equal to how much? 32x by 4. Or it is how much? 8x. So what is solubility will come from this? How much? Root 8x to 1 by 3. And that will come as 2 to power x to power 1 by 3. Or cube root of x. So that is solubility of this salt. And this question needs these two solutions are separated. They are not combined together. So we are getting that solubility of our salt is coming as 2 into x cube root. So now what was second one? Second one we have got. The second one is AgBr saturated solution is given. So you know it also lies at equilibrium with the ion. The ions are Ag plus and Br mix. These two ions are given, and they are at equilibrium. So let the solubility of this part is S dash. So at equilibrium, what is constituted of these ions? S dash and S dash. So it is very direct. So what is KSP of this salt? KSP of this salt will be S dash square. And that is equal to how much? The KSP is equal to 4y. Correct? So we can find the solubility of this salt. How much S dash is coming to be how much? It is coming to be 2 of y to power square root. Fine, so we are solving the question in this manner. We have to find separate solubility of each salt. So the solubility of second salt is coming to be 2 to power 2 into y to power half. And then what's question asking? Question is asking about ratio of solubility of these salt. So we have to find the ratio of S by S dash. So how much will come? It will come as 2 into x into y 2 into y square root. Correct? And even 2 is getting cancelled. So what is your answer? Your answer will come as here cube root of x by of y. This is the correct answer. So it was a good question. It was a highly conceptual question, but it was an easy question. And you're applying the concept of KSP and solubility here, but separated. Fine, it is not a question of simultaneous solubility. So this question will rate as easy question, not a tough question. You see, you find the solubility separately and then find the ratio. So which option is correct? You are getting the answer as this one. Is correct for this question. Fine. So this was the question, but it was an easy question. Fine. Yeah. See. So here's one question. It is a second question. Yeah. So see, this question is directly coming from, you can say, qualitative analysis, the color of the salt, and it is coming from qualitative analysis. So what is the question asking? It is asking that which compound will give apple green color in test. So I think this is a bit memory based, but we have to do it from qualitative analysis. So I think if you recall, calcium salt are actually brick red, and strontium are crimson red, and barium salt are apple green. And question asking about apple green in the same test. So definitely it is barium salt. This is fine. This is answer here. And so you see, this is the answer barium salt. Correct? So it was memory based, but very simple. Fine. So you have to just go to the qualitative analysis as well. Some questions are coming like that. I'll click on the testing of the salt. So answer is barium sulfate or this. Fine. Yes. Simple question. Next one is, you see, now this is a very good question. It is a highly conceptual question from the organic reaction mechanism. So it is that you see this compound is given to you, and question is asking that in the given compound, the electrophile attack will be favored at. See, first of all, if you look at the structure of this compound, see, one side we have got this is benzene ring, and this is CO group, and this is NH. Once again, it has to benzene ring. So that is the structure of this compound, correct? And what points are given to you? See, and R is given and S is given. So this compound is given. And question is asking about the of electrophile in the compound, electron loving. So that is electron loving. We can make it here. So see, this is a very good question here. You apply the UC part. You tell me here, like see, electrophile will always make an attack at the electron rich side of the molecule of the substrate. Now tell me that we can compare the effect of these two groups. So you see, CO group is what type of group attached to benzene ring? You see, CO group is deactivating group. Fine, it's a deactivating group. Because of this effect, it's a deactivating group. So that and what about NH group? You see, NH is highly activating group attached directly to benzene ring. NH is highly activating group. So usually in comparison, which group is more activated? NH dominant, and NH is more activating group. So it hot position. So it will by that ortho and para position. But because at para position there is no steric hindrance, so electrophile can better make attack at this para position because of more activation effect of energy group. So this will dominate over CO group. See, it will direct the meta position, but actually in comparison, NH is more activating and CO is deactivating. So NH is dominating and directing the electrophile to the para position. So usually electrophile will attack at this side. It should attack at the S side. So answer is A for this question. Correct? Answer A for this question. So it was a very good conceptual question, but again it was an easy question. We can apply the concept and we can get the answer. It was an easy question in fact. Yeah. So please have a look. Next, let us see in the next question. See, when you start organic chemistry, then first thing we always study that what is the priority order of functional group to name them. When a compound has what polyfunctional groups are there. So we always compare the functional group on the basis of priority given by impact. So I think if you recall that, which functional group is given the number one rank in the naming of compounds, that is carboxylic acid. So we are following that sequence. At which number two is sulfonic acid. And which number three, then all the carboxylic acid derivatives are there. Like we have got nitrite, then ester, then halide, then amide, then cyanide comes. You will call that. So see, like here carboxylic acid amide is here. So if we compare the priority order of this functional group, so see amide is will be top rank. Obviously, among that amide is top rank. And if you see after amide, see cyanide comes after that. So cyanide is there, so it will come at this position. And after cyanide, if you recall, then aldehydes come, aldehyde ketone, then alcohol, then thiol, and then amine, and then double bond and triple bond, and last is nitro like that. So that is coming to be. So who is number three? Aldehyde should be number three. And who is number four? Number four should be ketone. The ketone is number four, you see. And after ketone should come what? Amine. See, amine should come at this position. And after amine should come at the last. Yeah. So this is directly from your preference series of the function group in the priority order. So what the answer will be? What's the number of this group? 1. Then Cl is 4 and CH2 is 3. Ketone is 2 and H2 is how much? H2 is 6 and triple bond is 5. So this is your answer. Very, very good question, but very simple question. So till now all the questions are simple. Fine. So so according to this answer will be here C. Option C is correct. Fine. Your option C is correct. It is come back. C is correct. So very nice question and simple question here. So that is there. Let us see the next question. Yeah, see this question is directly from NCERT and it is a little bit memory based, but you have to do it. It's only vitamins. So what is the vitamin and your list two? So tell me, vitamin C is matching with ascorbic acid. Fine. Vitamin C is matching with the ascorbic acid. So one will match with C, and vitamin B1 is matching with thiamine, and vitamin B2 is matching with riboflavin. Fine. And vitamin B6 is matching with this pyridoxine. So this is your answer. So what's it? So one is matching with C, two is matching with A, three is matching with D, and 4 is matching with B. So your answer is this one. Correct? So it was directly from NCERT, very simple question, but little bit memory based. But this has to be done once. But so it was theory. So see, this is the next question. Yeah, see, this is a very from you can say from QC, and you tell me that it's a reaction of amine with the benzene diazonium chloride. So first of all, we have to see that what reaction this is. See, the reaction, it is a coupling reaction. You see, if you recall, it's a coupling reaction. So it's a coupling reaction. And the reaction of amine or phenol with benzene diazonium chloride is a coupling reaction. And what is the, if you recall, what is the fundamental mechanism of the reaction? So if you see, it is an electrophilic substitution reaction. Fine. This amine, like, amine is the electrophile will attack at the electron rich site of this amine, and an electrophilic substitution reaction will occur. And this diazoxide cation will act as electrophile. It will act as electrophile. So point is that tell me here which compound is most activated. See the compound which is most activated will easily in that compound easily electrophile can make an attack very easily, and that should be highly reactive. So tell me now among these compounds listed, which compound is highly activated? See, first one is aniline. So you know aniline is highly activated, and even there is no state like the and it's highly activated. So it can show pulsar effect. It can release electron very strongly, and then electron will come. So here the electrophile can make it easier tap. It is highly activated. But now if you look at second one, if you look at second one is looking activating. But here one point is going on here. See, if you look at that, see, our electron releasing. But at the bottom position, we have got one methyl acid. But you see here, both electron releasing. So there, we are increasing the electron density on the end strongly. But then what's happening? It's like at bottom position. And now what's the methyl will do? See, this methyl will create there is one concept of steric inhibition of resonance is going on here. So that process is acting here. So there is steric inhibition of resonance is going on here, which is called SIR effect. So that is acting here. Correct? Steric inhibition of resonance is going on there. SIR effect is going on here. So because of this, what is happening? See, methyl is actually blocking the lone pair to get deep on benzene side. So not lone pair will not be getting easily delocalized on this down side. So here activation effect is greatly reduced, and when that reduced, and so when we compare these two, so see this is more compound. This is less activity than this compound. So automatically reactivity with electrophile will decrease. So here electrophile can't make an easy attack as compared to this one. So out of these two, which is more reactive First one is more reactive than second one. And if you look at the last compound, you see here SIR effect is actually more pronounced. Because why? Now we have got two methyl groups lying at the bottom position. See, and here and two methyl groups are there, and even there are two methyl groups lying at the bottom position. So what they will do? See, they will create the steric inhibition of resonance effect more strongly, more heavily, and they to place on the benzene side, and they are blocking that. So here, activation effect will come very less, very little. So this should be least reactive. So because of SIR effect occurring or in these two compounds, what's the answer? This is most activity. So answer will be R. The number 2 should be P, and last number should be Q. This one RPQ. Fine. This option. Fine. Yeah. Please have a look at that. So this was a very nice question, and we are going with the concept of SIR effect, steric inhibition of resonance effect, and that is acting in second compound and third compound. But here it's acting more heavily, and we so because of SIR, our answer is coming in reactive is then P then this answer. Right? Yeah. So this was a nice question, and this was a highly conceptual question, but again not tough. Till now, all the questions are of you can say not tough. They are conceptual, but they are never tough. They are highly solvable. Yeah. Paper scoring till now. So you see, this question, yeah, this is the most you can say simple question from atomic structure. You have done Bohr's model, so directly it's coming from the Bohr's model. You see, can you, how to find the orbit angular momentum, not orbital. See, question is asking about it's orbit angular momentum of electron in the field of atom is this much. So it is asking about orbit angular momentum. So if you recall the Bohr's postulate, what was that? Because the angular momentum of electron is equal to NH by Q pi. That was the relation. NH by Q pi. So that this value is already given to you. It is PH by pi. So we can compare them, and when we compare, this will get cancelled. What NH getting 6. So see this was the most simple question in this paper. Fine, we can find N very easily. What is N is getting? N is coming to be 6. So now we know the orbit number. So the orbit number is going to be 6 of H atom. And for H, atomic number is 1. So tell me, if you know the orbit number, how to find total energy of electron? See, total energy of electron is given by, you apply the relation directly. Total energy is given by minus 30.6 by n square into z square electron volt. And we need an electron volt. So we can put the value. How much? Minus 30. And z is 1. So this is coming in electron volts. This is the value. Correct? So you see this, how do you write this question? Very simple. It was a very, very easy question. And when you solve it, so it's coming to be minus 0.8 volt. So it's coming to be minus 0.8 volt. This is the electron volt. Is the value, is the answer. Why? So this was your answer A. Option A. But this was the most simple question of this paper. And we can just do with the Bohr's model. Correct? Done. So you see, so this question done. Now let's see the next question. Yes. So this is again a very good question. And it is a highly conceptual question. Fine, it is easy but highly conceptual question. And this question is based upon the comparison of the strength of ligand from the electrochemical series. So we can no calculation is required here. See, we can compare the strength of ligand and we can find the answer easily. You see, all are octahedral complex, and where ligand we do crystal field splitting. But you tell me that listed which has got the strongest ligand. And we know very well that when the ligand is very strong, so strong ligand will do large amount of crystal field splitting, and then energy gap is very high, and then value of delta was also very high. So we have to only compare the strength of ligand. So tell me which is the strongest ligand? See the strength of ligand. Then our order should come like this. See the strength of ligand. So we compare here. So cyanide here is the strongest ligand you see. Among them, cyanide is the strongest ligand. So cyanide will do maximum amount of crystal field splitting in this octahedral complex. So energy gap is very large, and delta O will be maximum for this. Who is number 2? So you tell me number 2 should come to be in. You know, in is also a directed ligand. It is strong ligand, but it comes after cyanide. So in is at number 2. Number 3, should be what? It should be, you see, ammonia. Ammonia acts as a borderline strong ligand. So here, like ammonia will come here at number 3. And you know, the weakest ligand is chloride. So it is at the last number. Chloride is at the last. Typically, the strength of ligand is varying like this. And you know, stronger is the ligand, then higher is the crystal field splitting going on, and higher is the energy gap created. So answer will come accordingly like this only. Fine. So what will this will be? This study, if we having the you have to do the interesting order, which is the lowest. Right. So right B. See, B is the lowest. Then ammonia comes. So ammonia is C. Then E comes. E is D. And which is getting maximum crystal field splitting energy. So that will be A. So this is your answer. AD, ADCP. Fine, correct? So this is your answer, and this is correct. Fine. So it was a highly conceptual question. Fine, you're applying the strength of ligand comparison you're doing on. And with the help of that, we can directly find out the crystal field is splitting energy. We can compare that with the strength of ligand. Yeah, so please have a look at that. But it's an easy question, but highly. Yes, very nice. So it is being done in this time. Fine, correct? Okay. Let's do the next. Yeah, this is a good question. And this is a question from physical chemistry where some calculation is involved. You tell me till now all the questions that you've seen, they were without calculation. But this question concept wise is easy. But some calculation we have to do it properly in the exam. There should not be any calculation mistake in that. So it is involving some calculation. Let's see the concept behind in this question. See what is this question saying. First of all, you see fluoroacetic acid is an electrolyte. It is a weak acid. This is fluoroacetic acid. But you know, it is a weak acid. But it is a weak acid of what type? It is of AB type. So where it will dissociate? So there is a equilibrium setup, and it will give you this anion, this CO2F, CO4 minus and extra sign. So it is of AB type, but it is a weak acid. So first thing is this. Let's say we have taken 20 grams of the acid, and point is 1 degree. Then calculate K of fluoroacetic acid and assume molarity to be molarity. Fine, very good. So see, first thing is that because we have taken electrolyte, which is getting dissociated, so we have to apply the quantum factor I. Correct? We have to apply the quantum factor I. So we should find that first of all. Okay, see what is the molarity of the sleep? See, is equal to I into K into molarity. So we'll go with this relation. And obviously, K value will be given during the question. It is memory based, but K value will be definitely given to you. And we even, I think K for water is the we remember every time K and KB for water. We remember every time. What is K for water? We know that K for water is 1.86 Kelvin kg per mole. That's K for water. So that we know very well when we solve the questions. So memorize K and KB of water is the most common. So now we will put in that. What is delta TF? Delta TF is given to be 1. I we need to find TF is 1.86. And what is the molarity of this solution? So that's the Boltzmann solution, which is 20 by molecular weight. You can find it will come as 78 by weight of solvent in kg, 500 by 1000. Fine. So this is your calculation will be. So first of all, you will solve this. Fine. And you will find the I from here. I'm just telling you the method how we're going to solve it. So we can find I from here. And I think if we just solve I from here, so I is getting to be 1.048. Roughly, this is the I is going to be 1.048. So see, the first step in solving this question, first of all, you find the I value that is needed. So I value is 1.048. So we obtain that. Now see, once we obtain I, now what is the next step should be? Once we obtain I, then we should immediately go for alpha value because it is a weak acid. So alpha is there. So if you recall, what's the relation of I? For dissociation case, there's a very important relation. You know, I is equal to 1 plus L minus. We will apply this and we'll find alpha from here. Because once we get alpha, then we can solve this question. Fine. So we'll go with this. How many ions are formed on the right side? How many ions are there? 2 ions are there. So N is 2. So we'll put up there. See, I 1.048 is 1 plus 2 minus 1 alpha. So this is 1 plus alpha. Correct? So from here we can find alpha value. What is alpha is getting? Alpha is coming to be 0.048. Fine. Once you find the alpha value, so now we can find what question asking. Question is asking about the K value of acetic acid. K value. You tell me this electrolyte is of what type? Although it is a weak acid, it is of what type? It is an AB type. So this weak acid is of AB type. And if you recall, for AB type, what's the relation of K? You see the relation of K for AB type comes as C upon. Correct? So we'll go with that relation. But before that, we have to see check the type of electrolyte. What type of electrolyte that is? It is AB. For A2B type, the relations are different. And for AB3 type, they are different. But now we'll go with that relation. Because of AB type. So we'll go with A is equal to C alpha square alpha, where C is the molarity of the solution at the start. And alpha we have just found. Because alpha is not so high, so we can also discard alpha in the denominator. So we can approximate it to K is equal to C alpha. And from here we can find what C will be. Question is saying that assume polarity to be molarity equal. They are equal. So we can also take polarity here. And what's the molarity of the solution? It was how much? 20 by 20 is the moles by weight of solid 500 per 1000 is the molarity. Also equal to molarity into alpha square. And alpha is how much? Alpha is 0.048. So yeah, this was the question which is involving some calculation there. And we have to be perfect at the calculation so that we can attain the right answer. See, even you're very strong with the concepts, but answer have to be attained lastly. So here you see it is involving this sort of calculation, and we have to solve it completely. So you see, this was the concept behind solving this question here. So once you solve this calculation, so, but it has to be done accurately. You should do it accurately to get the right answer. And this was the concept involved in this question. So this was a very good question. Conceptually, it is a very good question, and it's also involving some calculation of this type. So when we solve this, then we definitely get an answer from here. Why this is method of solving this question here? Yes, yeah. So I think it is this type. So it is coming to that. This is a method of solving this question. Right? Yes. Fine. Let's see the next question. Yeah. See again, this question is again a very simple question from thermodynamics. Why? The reason is that can you see the PV graph? So you can see the PV graph, and the question is simply asking about work done in the process from A to B. So see the point is that it's a PV graph, and you tell me that see this graph is falling like this. So definitely see, the graph is for reversible process, but not whether it is isothermal or not. We can check. See, how can we check? Like we can check that whether this graph is for reversible iso expansion or not. So we can check that. See, T will be constant. So PV should be constant. See, if it is isothermal, then PV should be constant. It should be constant. So we can check that. Tell me at the point of the graph, what's the value of PV? See, at point K, the value of PV is P is how much? P is 8 atm and volume is 0.5 liter. So PV is this much coming this liter. How much is it? 4 liter at point A. Correct? And we can also check at point the final point. So at the final point B. So at the final point B, what is PV value? Now PV value will be 1 and volume is 4. So you see what is PV is it is also 4 liter ATM is coming. So you can check that if in the graph, if the value of PV is constant at every point of the graph, fine. If the value of PV is constant for every point of the graph, so this means that temperature is constant here. Fine. And in this graph, you see PV is constant for every point of the graph. So temperature is constant. So this graph is for isothermal process. And because the graph is falling curve shape, it is hyperbolic. And this graph, so what is the process going on here? We can say that a process is going to be isothermal and reversible expansion. Isothermal and reversible expansion is going on. Isothermal, isothermal and reversible expansion is going on. Correct? So please have a look at that. Here, isothermal and reversible expansion is happening. That is confirmed. Well, now once that is confirmed, so we can find the work done with the expression of isothermal and reversible expansion. You know very well. I think the most elementary concept you can say. So how to find the work done for iso and reversible expansion? So we obtain by minus of 2.23 nRT log this 10 B2 by B1. So we can apply that expression. But again, one change is here. Here temperature is not given. You can see in this question T is not given. But no problem. You know PV is constant now. So what is PV equal to? nRT. So in case of nRT, we can put PV. But PV at one point we can put. So see, we can put either initial or final. So see, we can also write as because we know that PV is equal to nRT. And nRT is constant. Constant. So that's so we can put PV at one point. So what we can do, we can put here minus 0.23 into PV. We can into log P or and we can solve it. So what we get point 20 PV. What is PV initial? Already we find that 4 is coming, 4 liter is coming into log base 10 V2. What is final volume? 4. And the initial volume 0.5. So it is coming to be how much? Log 8 and log 8 for 2 log 3. Log 3. Log 2 cube, sorry. 3 log 2. And we can solve it. So that's a good solve. When we solve it, this answer is coming to be 8.3 liter is coming constant. Yeah, so you see, this question was very simple. The point was that you have to catch up that in this question, what process going on? See, the point is that because the graph is curved and so and then check whether it's isothermal or not. So it's, why? Because at every point of the graph, they be constant, so it's isothermal. So that's why we are going with the expression of iso and reversible expansion. We are applying this. And with the help of that, we are finding this value. So for the correct answer, B is correct for this question. Right? But question was very simple and little bit calculation was there. So we have to reach to the final answer with the proper calculation. And we are solving question. Easy question. Find it? Yes. So that was good. Yeah. You tell me that I think this question, this concept and this question, you have seen number of times. And even this question has repeated number of times in the base paper. And again, it has come, you see. So I think this, can you recall the method? What is this method? I think if you recall, this is a cumene method of preparation of phenol. If you recall, this is a cumene method of preparation of phenol. Directly, by looking at point, this is a cumene method of preparation of phenol. Or tell me, what's this one? This is isopropyl benzene or cumene. So I think we know very good that it has got a proper mechanism. So this compound is what? This compound is isopropyl benzene or cumene. So when we oxidize in air, when we go for aerial oxidation, when we go for aerial oxidation, so first of all, this compound gets what? Cumene hydroperoxide. Cumene one peroxide now is coming. It goes to cumene hydroperoxide, and we get in this compound. See, we are getting this one. Cumene hydroperoxide, and then we are going for hydrolysis. So hydrolysis will be with a proper mechanism. Phenol and we are getting phenol and but it just come number of time in the base paper. And again, it doesn't come in the paper. So what's the correct answer? Correct. The answer E is that. Right? This phenol and that's final. So this was a very simple question for the method of prediction of phenol. Yeah, please have a look at that. That is done. Next question, let's see. Here This is a very simple question. I think this is the most elementary part we do. You tell me what is the general reaction for combustion of any hydrocarbon? We can once check that. So you know very well that the general reaction part. So I think this is the most elementary part. Like when we start that, so we always take into consideration that. So the most elementary part is the reaction H5 plus X plus Y by 4 O2 will give you XCO2 and Y by 2 H2. So this is your general reaction going Y by 2 H2. Correct? So we can use this reaction. And what is the question saying? LP say 8 would we want 8 or 2? We want 8. So why not go with the answers? We can put the here. Like if we take C for S10, if we take C for S10, we can go with that. So if we take C for S10, X is 4 and Y is 10. So 10 by 4. How much we get? 4 plus 5 by 2. How much we getting? 13 by 2. We're getting 13 by 2. So I think we are getting 8. So we can apply elimination method. So this is not as we can take second one. What is second one? C5 X12. So we can apply that. Now tell me what's the value of X plus 5 by 4? X is 5 and Y is 12. 12 by how much? 5 plus 3. This is C. Directly makes coming. So we got the answer. See, this type of question has come in this paper. So it is the most simple question, most elementary question. We can apply this reaction and we can do it. So this was correct. Well, here, that's the answer. The most elementary question. Right? So that is being the yeah. The most simple question is this. Let's see this one. The correct increasing order of bond length among the following. So this is a good question, but we have done this example number of times. So you see, it is from molecular orbital theory. We can find the bond order of each species. And can you recall how is bond order and then correlated? So you know that bond order is inversely proportional to bond length. Correct? It is inversely proportional to bond length. Correct? Higher is the value of bond order. So higher is the multiple bond between two atoms. Higher is the number of bond between two atoms. That will decrease the distance between the two nuclei of atom and bond length will fall down. So higher is the bond order, shorter is the bond length, and vice versa. So we can apply this concept and we can get the answer. Let's have a check on that. Suppose we'll start with O2. So we'll apply the molecular orbital configuration of O2. Fine. And you know very well that what is the molecular orbital configuration for sigma 1 is? Sigma 1 is star. Sigma 2 is or sigma 2 is star. Sigma 2 is that we are going for O2 16 electron. This is for 16. Sigma 2 is and then 5 to be X and 5 to be Y. 5 to be Y and then Y to be X and Y to be and then sigma. So we'll go with the sequence and we'll fill up 16 electron here. 16 is what? 2, 4, 6, 8, 10. But here they are degenerate. So we will go with one stool. So 1 and 1 and then 1 and 1. So how many are done? 2, 4, 6, 8, 10, 12, 14 and 1, 1, 15, 16. So that is O2. So what is the bond order of O2 is coming? Half of bonding electron, how many bonding electron? 2, 4, 6, 8, 10. And how many anti-bonding? 2, 4, how much? 6. So how much we get? 4 by 2, which is yes. So you see the bond order, we can find the bond order and then we can compare. So the bond order from O2 is 2. Correct, fine? Now tell me what about O2 plus? O2 plus means in the O2 plus, one electron taken out, one electron taken outside. So tell me, you will take the electron from where? You will take the electron from higher anti-bonding. Higher anti-bonding. Or you will just eliminate the electron from higher anti-bonding. So tell me now, in O2 plus, which is about 15 electrons, what's the bond order will go? Half of bonding. Now, what's the bonding electron? See, anti-bonding electron is getting less, but bonding electron is same. How many? 2, 4, 6, 8, 10. How many anti-bonding are 2, 4, and only 5? Yeah, you see, that is correct. So, how much we get? 5 by 2, which is 2.5. Which is 2.5. Correct. And we know higher is the bond order, shorter is the bond length. Yeah. So, for O2 plus, what about O2 minus? See, for minus, it will be one electron is it has got how many electron? 17. So one electron is added, and when one electron is added, that electron will enter where? That electron will come here. See, one electron is added, will come here. So one anti-bonding electron is added, correct? So that will come here. Now can you find the bond order here? No. How many bonding electrons? See, bonding are same only. But anti-bonding electron will rise. So let's look at bonding electrons are how many? Bonding are 10 only. But how many anti-bonding electrons there? See, anti-bonding electrons are how many? 2, 4, and then 5, 6, 7. 5, 2. How many is 1.5? 1.5 is O2 minus. Correct? So see, O2 minus is 1.5 is the bond order for O2 minus. And what about O2 minus? I think O2 minus. So what about O2 minus? For O2 minus, one more. See, how many electrons are there? 18. So one more electron is added to O2 minus. So where does that electron will come? That electron will come again in this anti-bonding. So again, one more anti-bonding electron is getting higher, is getting raised. So now, what is the bond order will come? How many bonding electrons is there? They are same 10. But how many anti-bonding electrons is there? See, anti-bonding electrons are 2, 4, and then 6, 8, 8 by 2. So how much is 2 by 2? 1. Correct? So you tell me now, so we can find the bond order like that. Now tell me which has got the highest bond order. Highest of O2 plus. So you know, you go with this concept. So O2 plus will be having the least bond length. The least bond length. Higher is the bond order, shorter is the bond length. Then who will be next number? O2. Is that O2 plus is last? Then O2 will come, and then comes this is the O2 minus will come, and maximum will be O2 minus. So this was a good application of molecular orbital theory. So we are doing like this. Fine. What is the best part of doing it? Just write down the configuration and apply electrons properly, and find the bond order, and then you compare. So this should be done. Fine. So you can compare. We have to find a this order. This is the. So which option is correct? Or option A is correct. Yeah. Option A is correct. Very, very nice question. Highly conceptual question. This is. We can solve in this manner. Fine. Done. It was a good question. Yes. So please have a look at that. Let's see next one. Yeah. This was the integer type. Okay. And you tell me now, it was a very good question. And it is also involving some little bit calculations there. You tell me that. See, it is a first order reaction. Rate constant is given at 7 degree and T degree. So you know very well that rate constant depend upon temperature, and that variation is given by Arrhenius equation. So we'll apply this form of Arrhenius equation. Of this 10, K2 by K1 equals E by 2.23 R into 1 by T1 minus 1 by T2. Correct? Because here temperature is varying. So we should apply this form of Arrhenius equation. Fine. Now it is there. Now, so you tell me that at 7 degree K is given and at T degree K is given. So we will take this T1, this is T2. Yeah. So what we are getting? Log base 10, K2. What is K2? 4.5 into 10 to the power 3 is K2. And what is K1? K1 is 1.5 into 10 to the power 3 is K1. Correct? Equal, what is the activation energy also given? How much is given? See, activation is 60 kilojoules. But you convert it into joules. So 60 into 10 to the power 3 joules upon 2.23 R. What is R value? Say R 131 joules. So now both are in joules. They are compatible. Into 1 upon T1. What is T1? T1 is your initial 300 minus 1 upon T2. So this T2 will be in Kelvin. So first of all, we can solve this calculation. Calculation was there. Or in this question. A little bit discussion was also calculated here. And you have to do the right calculation to get the answer. But concept is see, concept is very simple. You see, concept we are simply applying the Arrhenius equation. Fine, and we are using this. So what this has to be solved. How much is it? Say log 3. This is log 3. And log 3 is what? 0.4771. Equals how much is it going to get? Yes. 6 is getting 2.3 into 8.31 into 1 upon 300 upon 3. We're getting this. So then we can solve it. Fine. So you you see, so calculation wise, the question, some calculation are here, but concept wise it is very simple. But we have to solve, we have to make the calculation perfectly. So here, finally, what you getting T2 from here? T2 will get in Kelvin. See, T2 will be in Kelvin, but they are asking in what? They are asking in degree centigrade. Yeah, that point was there. So we have to be careful with that. See, T2 is coming in Kelvin. In Kelvin. So we convert it to degree centigrade. Fine, so T degree centigrade is T in Kelvin. So we have to subtract what? We have to subtract T minus 270. We have to do this. Fine. And if we do this calculation, so answer is approximately coming to be 41. You will check it. The answer is coming to be T, small t is coming to be 41. This is a 41 is different. Fine. So this was a very good question. Very simple question. It was not tough. Directly one concept you're applying RDS question, but with proper calculations. Then you're getting the answer easily. Right? So this is your answer. Yeah. 41 is, and we are doing this. Correct? Yeah. But it was and yeah, also a very good question. You can say it is a very good conceptual question. Fine, and you see, but it is a simple question, not done. See, what is given here? You see, one complex is given. Of this complex is here, CLX, H2O full Y, and Cl3 minus X, and H2 6 minus Y. Yes. So you see, this complex is given, and its 8 grams given, and it is reacting with silver nitrate to form 8.61 grams of AgCl. Fine, very good. So see, the point is that here we have to first of all see, confirm that how many Cl outside the condition sphere and how many Cl will lie inside. That we have to see. Now, this is also here. You see, what's the overall formula? See, this is x and this is 3 minus x. So when we, what is formula getting Cr? Cl3 and H2, how much? When we add, so y is getting cancelled 6. So its formula is this. Right? That molecular formula. So what we can do? Can you find the moles of this compound? Yeah. See, we can find the moles of this compound. How much? The moles of this compound is 8 by its molecular weight. Whatever is the molecular weight? 8 by molecular weight of this compound. That's the moles. 8 by is the moles of this compound. Correct? Now, what is happening? Obviously, some Cl are outside the condition sphere and some are inside. So that we don't know. But we can confirm with the PPT which is obtained. Fine, you see that. What's the next point? How much gram of AgCl PPT are you getting? See, what's happening here? All the Cl minus, which is ionizable from this complex, is combining silver nitrate and forming the PPT of AgCl. Forming the PPT of AgCl. In the constituent ratio. So we can find the moles of AgCl PPT. Fine. So what is that? What is the moles of AgCl? See, the moles of AgCl will be 8.61 by the weight 143.5. Correct? So we can find the moles of this thing. And see, this is coming to be every good cell. It is coming to be 0.06. It is coming to be 0.06. Fine. So that is there. And so this is the moles of HCl PPT. So what is the moles of HCl? The moles of Cl minus also that be. You see, in what mole they are reacting? 1:1 type. So if this is the moles of PPT, then what's the moles of Cl minus should be? Also equal to 0.26. Also equal to 0.26. So the mole of 6, and this was the ionizable Cl, not the Cl inside the coordinate sphere. This was the ionizable Cl, 0.06. And now, like if you put the molecular weight of this complex and then we solve it, so that calculation already we see that's coming to be 0.03. See, that's coming to be 0.03. So you tell me that. So now can we correlate with the mole concept? You tell me 0.03 mole of complex is giving you how many mole of ionizable Cl minus? How many mole of free Cl minus? 0.06. So you see, we can correlate here. 0.03 mole of complex is giving how many mole of Cl minus? 0.06 mole of Cl minus. So better we can find 1 mole of this complex will give how many mole of Cl minus? 2 mole of Cl minus. Correct? 2 mole of Cl minus. So tell me 1 mole, 2 mole of Cl minus. So this means what? If you get 2 mole of Cl minus, so they are divisible. So outside the coordinate sphere, how many Cl should be 2? So 3 minus x is 2. But x is 1. When x is 1. So when x is 1, what is formula will come? Cr, Cl. And if see, there is one right side. So number of particles should be 5. Because you know the coordination number of Cr is 6. So 5 particles lie inside. And it is 2. When x is 1, see x. And y is 5. Y is 5. So how many particles come outside? Only one particle comes outside. So you see these two values are coming. And from here you see x is 1 and y is 5. So these are the value of x and y. And once you get the value of x and y, fine, please have to that. So this question was involving the whole concept. And it was a very good question, very good conceptual question, but not difficult. It's an easy question. We should solve like this. Fine, we should correlate with the mole ratio. Find a mole of complex, find a mole of AgCl, find a mole of Cl minus, correlate. You find 1 mole of complex will give you how many mole of Cl minus? It is 1 type, and it is 1 type. So 2 Cl will be outside, 1 will be inside. So then 5 will be inside. Why? Because the coordination number is 6 of 0. So 1 by 3. Yeah. So x is 1 and y is 5. And we need the value of x into y. So what is x into y will come? Yeah. You see x into y will come as x into y will come as x is what? X is 1 and y is 5. So it is 1 and 5. Just 5. So 5 is the right answer. 5 is the fine. It was a very good question. You see, overall in this paper, some questions were very conceptual, some questions were very simple. So the level of paper was easy to moderate, highly scoring paper. But it's not highly scoring paper. But again, then competition will be so much in this paper. But paper was very good. Highly scoring paper. So, fine. So I think so all of you have just write maximum question in this paper, and it was highly scoring paper. Yeah, thanks.